can see the it stopped. So welcome everyone to the 10th session of SAIMA. Who we are and what we want to achieve is this. So it's a group created by the technical architects. People like Johan, Lilith, Meera, and Neha. They have started the group and they help prepare for the certifications and make room for learning and study. If you would like to present in the future, please let us know so we can schedule the next topics with you. Who are today's speakers? Well, I'm your host. I am Salesforce consultant at Makina, and I'm Salesforce application architect certified, and I plan to finish my system architect this year itself. And we have three amazing speakers. So our first speaker is Jiji Jayasingh. She's an enterprise solution specialist at UST Global, and she's a woman in tech Kochi co-leader as well. Even she is a nation, and she plans to finish her system architect this year as well. The next speaker we have is Manoj Nambirajan.
I think we lost her. That's okay.
Yeah, we sure did.
Manoj, you can introduce yourself, and Kid, you too, while she's out.
Yeah, sure. So hi all, this is Manoj. So I am part of Dell Digital handling enterprise architect responsibility for Salesforce implementation in Dell. So my IT experience is like 15 plus years with 13 plus years mostly in Salesforce platform. And I thank you, SAIMA, for this opportunity in sharing my insights for the content today. Thank you.
I'm sorry, I dropped off. Let me share my screen again.
Yeah, that's okay. What for you?
Okay. Yeah, so you're still able to see my presentation, second slide? Yeah, okay. So I heard Manoj giving the introduction.
Et de la séance de communication. Bonsoir, bonsoir à tous. La nuit tombe.
Sorry? Did someone say something?
No, I think it was an accident. You can continue, okay. I think.
Okay, I'll skip to the next slide. The most important before I hand over to the speakers, the disclaimer, we are just volunteers. We are not part of Salesforce Architect program. And we cannot guarantee that our info is always correct. We are just presenting. Based on what we present, if you would like, please check the updated, all the official documents from Salesforce for your reference. And lastly, the next is a bit housekeeping rules. Please mute yourself during the conversation. Ask your questions on the chat. I will make a note of all the questions. But at the end of all the three presentations, please feel free to unmute yourself and ask the questions directly. Yeah, that's it. So welcome everybody, and I'll probably stop sharing and hand over to Jiji, our first speaker.
Thanks, Shruti. Thank you all. So I'll just start sharing. Hope you can see my screen.
Yes, we can.
Okay. Okay. So good morning, good afternoon, and good evening, everyone, based on the time zone. Thanks for joining today's session. So myself, Jiji Jayasingh. I have been working in Salesforce for over 11 years now and have worked on almost all the major areas of Salesforce like Sales Cloud, Service Cloud, Einstein, Integration, Aura, Salesforce DX, etc. So I am an ATEX certified application architect and I hope to complete the system architect certification as well this year. Also, I am a Women in Tech Kochi Group co-lead too. And today's topic is about bulk API using PK chunking. I have had the fortune of working on multiple complex SF implementations. In one such project, we had a requirement to retire a set of features. As a result, a lot of data had to be extracted and archived. We used PK chunking for this scenario, which made our task really easy and faster. So as this is related to data, we can first go through the basics of managing data. Getting the correct data, manipulating and managing it, obeying all the rules that the system enforces, and load it correctly is always a headache, especially if we are dealing with millions of records. To start with, we need to understand the basic concepts while fetching data. Custom index and Salesforce ID or the record ID are the two parameters used for easy and quick retrieval of data. Salesforce support custom indexes on the custom field, which help us to easily locate the rows without scanning every row in the database. Index contains sorted columns and pointers to the rows of data. And the query uses these index columns to quickly identify the data rows without scanning the full table. The next parameter is the Salesforce ID, which is the 15 character or 18 character ID of a record. This is the fastest way to find a record in the database if you are using the record ID in the where clause. As you all know, bulk API provides the programmatic option to quickly load or retrieve your orgs data to and from Salesforce. Bulk API is based on the REST principle and is optimized for loading or retrieving large set of data. We can use it to query all, insert, update, upsert, or delete many records. But if your table is massive, then the bulk query usually time out or gives errors as it finds it hard to complete the process. Here comes the usage of PK chunking. PK stands for the primary key, that is the ID of a record, which is always indexed. This is a feature enabled by Salesforce in Spring 15. We can add a few parameters for the bulk API jobs, and the platform will automatically split the queries into smaller chunks based on the record ID. This makes the larger queries manageable while using bulk API. The query is divided into smaller queries, and each query will retrieve a smaller portion of data parallelly, thereby making the process easy and faster. The extra queries are run with successive boundaries, and the number of records to be retrieved by each query is called the chunk size. So each query will retrieve maximum number of record as a chunk size. The first query retrieves the record between the specified starting ID and the starting ID plus the chunk size. And the next query retrieves the next chunk of record, and the process will continue until all the data is retrieved. For example, let's say we are going to query account table that contains 10 million records, and the sample query for this process will be select name from account. If we have enabled PK chunking and have specified the chunk size as 250,000 and have set a starting ID as one of the record ID, then the query is split into the following 40 queries. And each query is submitted as a separate batch, and they will retrieve the records corresponding to the ID we have mentioned in the where clause. Now we can check when to use PK chunking. Salesforce recommend enabling PK chunking if there are more than 10 million records in an object to improve the performance. And if the bulk query consistently time out, in that scenario also we can use PK chunking. PK chunking is supported in most of the standard objects, all the custom objects, sharing and history table of the supported object. Now we can go through some of the common errors that we face during the data management. First one is the non-selective query against large object. That means the query is not selective enough to find the exact result in the large object. Second problem is no response from the server. That is, the query takes too long time to respond. The third error is time limit exceeded. That is, the request exceeded the allowed time for processing the request. And the fourth problem is too much data retrieved by the query, which will hit the governor limit 50,001 or the remote response size exceeded maximum of 15 MB. Now we can check how PK chunking work in a simple analogy of fetching people in a city. We can go through each of the problem that we have discussed in the previous slide. The first issue was non-selective query, and a sample request for this scenario is get me all people who wear an eyeglass. And the response from the server is I give up, because it find it hard to find the entire result from a larger area. The second problem was query timeout, and the sample request for this issue is find me a 7-foot tall person in a pink tuxedo. And the response from the server after searching all the day, I can't find any, I give up, because it couldn't find the exact result from the larger area. The third problem was too many results returned, and a sample request for this scenario is find me all people who are above 40 years of age. And the response after searching 10 minutes, the bus is full. And the system couldn't retrieve the entire data because it already reached the maximum result that it could attain. PK chunking addresses all these problems by divide and conquer mechanism or parallelism. We can check how PK chunking helps us to solve these problems one by one. So the first problem was non-selective query. So the sample request or the modified request after enabling the PK chunking is get me all people who wear an eyeglass in your small search area. So we have added a new phrase called in a small search area while enabling PK chunking. And the response from the system is with pleasure, because it is easy for the system to find the results from the smaller area. The second problem was query timeout. After enabling PK chunking, the modified request will be like, find me a 7-foot tall person in a pink tuxedo in your small search area. And the response from the server is, from area 1, didn't find any, sorry. From area 2, didn't find any, sorry. From 3, found one. And from area 4, didn't find any, sorry. So it could find the exact result as it is divided into different or smaller area. And the solution for the third problem after enabling PK chunking and the sample request would be like, find me all people above 40 years of age in your small search area. And the response from the system is, from area 1, 20 people in our bus. From area 2, didn't find any. From area 3, 50 people in our metro. So the system could retrieve the maximum or the exact result as it is divided into smaller area. Now we can check how we can enable PK chunking. As we have mentioned, we need to add a certain parameter to the bulk API request header to enable PK chunking. The first parameter is the field name, and the field name for enabling PK chunking is sforce enable PK chunking. And the field values are true and false. True means enable PK chunking, and false means disable PK chunking. So if we are not mentioning the field name in the request header, that means PK chunking is not enabled for the bulk API job. The next parameter is the chunk size. Chunk size is the number of records that each query, each subquery or each chunk can retrieve. The default value is 2000 and the maximum value can be 250,000. So this is not mandatory. So if we are not specifying the chunk size in the request header, that means the default value of 2000 will be taken for the processing. The next parameter is the parent. We need to specify the parent object when using the PK chunking for queries on sharing or history table. And the last parameter is a start row, which is the 15 or 18 character record ID. And the start row will be the lowest boundary for the first chunk. So this is a sample request header after enabling PK chunking. So the request header will contain the sforce enable PK chunking, chunk size, parent, and the start row. Now we can check how we can enable PK chunking in different bulk API tools. First, we can check how we can enable it in Workbench. So in Workbench, under Utilities and under Rest Explorer, we can enable a post to initiate a bulk API job. The keyword for the bulk API job is async in the URI. And the post will contain 3 sections. One is the URI, then the request header and the request body. So in the request header, we need to specify the parameters corresponding to PK chunking. So here we can see we have enabled the sforce enable PK chunking and the chunk size is specified. And also we have the request body where we need to specify the operation and the object on which we are doing the operation. The request body will be in the XML format. So once we execute this URI, the system will return a raw response, and this raw response will contain an ID parameter, which is the ID of the job that we have initiated as part of this bulk API job. And this raw response will contain other information like number of batches queued, number of batches in progress, number of batches completed, number of batches failed, and the total number of batches. So if we want to check the status of a particular job that we have enabled as part of the bulk API job, we have an option called bulk API job status under utilities, and we need to specify the job ID that the raw response returned to us after executing the URI to get the status of that particular job. To get the result of that particular job, we need to create a GET request, and the GET request format and the sample URI will be like services/data/version/jobs/ID of the job and /result. So while executing this URI, the response shows the results of the SOQL query that we ran as part of the job. So this is how we can enable PK chunking in Workbench. Now we can check how we can enable PK chunking in CURL. CURL is nothing but client URL, which is the command line tool used for data loading. So to enable PK chunking in CURL, we need to execute a certain set of scripts in sequence. First, we need to log into the Salesforce org from which we need to retrieve the data. Then we need to run the below script in the developer console to get the session ID, because session ID is used in the CURL scripts to retrieve the data correctly. So the session ID is unique to a particular org, which contains the information about the organization ID and the session ID of that particular org. Then we need to create an XML file called the create_job.xml, and we need to save it in our local folder. And this XML file will have the information like what operation we are doing and on which object we are doing the operation. So here the operation is query and the object is account. Now we need to open the command prompt and navigate to the local folder where we have saved the XML file using the cd command. Then we need to run the below script to start the PK chunking job. The script is curl-h, session ID, content type, then the parameters required for enabling the PK chunking, that is a S-force enable PK chunking equal to true. So here the other parameters are not specified. If it is needed, we can specify that too. Then create job.xml, which is the XML file that we have created. Then instance URL/services/async/version/job. So by executing this script, the PK chunking job will be initiated and Salesforce will return an XML response which has a job ID in the ID string. So we need to create a query.txt file, and this text file will contain the query that we are going to execute to retrieve the data. And here the sample query is select ID name from account. So we are going to retrieve the records from account object. So this query.txt should be saved in the same folder where we have saved the create_job.xml file. Now we can run the following script to start the query batch. So the sample script is curl-d query.txt-h session ID content type instance URL/services/async/version/job/job ID/batch. So here we need to specify the job ID we got from the raw response that XML provided while executing the first script. So here, while executing this script, Salesforce will return another XML response, and this response will contain the ID of the first batch that is initiated as part of this execution. So this will contain both the job ID as well as the ID of the first batch. To get ID of all the batches in the job, then we need to run the below script in the CMD, that is curl-h session ID instance URL/services/async/version/job/job ID/batch. So while executing this script, it will give all the ID of all the batches that is initiated as part of this job. So the base script is curl-h session IDs, then instance URL/services/async/version/job. So we need to append different parameters to get different information as part of this job. So to getting all the ID of all the batches, we have appended job ID/batch. To monitor the job, we can specify the job ID in the base script. While executing it, the status of that current job will be returned. Then to monitor a particular batch, we need to append /job ID batch and batch ID. So the system will return the status or the status of that particular batch. Then to monitor all the batches, again, we need to append the batch keyword. So it will return the status of, the ID and other information regarding all the batches. Then to get the result ID, we need to append the result keyword to the base script. So this will return the result ID for that particular batch. So this result will be corresponding to that particular batch. So this result ID will be unique to a particular batch. To retrieve the result corresponding to that result ID, we need to run a script. For that, we need to append the result/result ID keyword, and the output will be in the XML format. We can also extract the output in a CSV file or an Excel file. And for that, we need to append the name of the Excel file to the script. So this will create a file if it is not available in the local folder already. It will create a new file and write the results to the file. And if all the results or the results corresponding to all the batches are completed, we need to close the job. For that, we need to create a file called job.xml, and in that we need to give a tag called state tag, in which we need to mention the state as closed. And we need to run the script in the command line, which is curl-h session id content type -d close job.xml instance URL services/async/version/job/job id. By running this script, the job will be closed, and that's about how we can enable PK chunking in CURL. And of course, PK chunking is having some limitations. PK chunking cannot be enabled for queries which is having an order by clause or where clause on any ID field or limit clause. And enabling PK chunking in data loader is still an idea. And each chunk is processed as a separate batch that counts towards our daily batch limit. To summarize the topic, to extract tens or hundreds of millions of records from Salesforce for better performance and reliability, we need to split the job into a set of separate queries, and we need to run these queries manually to retrieve the smaller portion of data. And then we need to integrate all the results to a complete set. The new PK chunking feature of the bulk API automates this process by using the primary key of an object to break up the data into manageable chunks, and each chunks will be executed separately to get the entire results. And this feature is enabled for all the custom objects, most of the standard objects, and their history and sharing table. I have enclosed some of the references that I have used while preparing this topic. That's all from my side. Thank you. And I would like to thank SAIMA team for giving me an opportunity to present my topic before all of you. Thanks again.
Thank you, Jiji.
Yeah.
If there are any questions, please drop it in the chat for now, or else at the end of the session, you can also ask the questions. The next speaker, let's hand it over to Manoj.
Yeah, sure. Let me share my screen. Once again. I hope you all can see my screen.
Yes.
Yeah. So hi all, this is Manoj. I'm the enterprise architect for Salesforce in handling the Salesforce practice in Dell. I'm Salesforce certified application architect with 2 times Trailhead Ranger and 12 Salesforce certifications I have. So now, as we learned from Jiji on the criticality of PK chunking in handling large data volume, now I take this opportunity to share my insights on large data volume considerations in Salesforce. So let's move on to the agenda. So what I'll be taking you through are a few of the preparations that you need while handling the large data volume, the large data volume use case, as well as the solution concept. And there are a few gotchas which I'm sharing, which you can consider as a guideline as you prepare for large data volume. So let's get it rolling then. Let's move to large data volume preparations. Now, as a Salesforce citizen, right? I think we all are Salesforce citizen because we practice in Salesforce platform and we end up managing large data volume in any instance. And we, as far as I understand, there are three pillars that you need to have an awareness and get an understanding in your group to help you design a solution for a large data volume or handle any large data volume related situations. So to begin with, it's the object model, because as we all know, object schema is essential, right? I mean, it defines the object relationship. You will come to know how the objects are interconnected, maybe the lookup relationship or master data relationship. That's the construct of or the metadata of the object, right? So once you know the object model, it can actually help you handle few of the situation. For instance, data archival. So if you take data archival, for example, we all know the moment you try to archive, in the sense maybe deletion of data, right? If you just take that concept to deletion of data, the moment you delete a parent record, then the child record is automatically deleted. So you're not able to archive that because the deletion has totally taken out the child record from the instance. So once you know the object model and know which object is a parent, which one is a child, then you can plan your data archive in such a way that you can start with archiving your child object records before you go to the parent. So the object model or object schema understanding will help you in planning your data archival strategy accordingly. And similarly, ordering of data when you're pumping large data volume into the instance. I think we all know, I mean, if you take opportunity and line item as an example, right? So opportunity acts as a master and line item is a child. So if you get a use case of pumping line item data into the instance, then the standard best practice of Salesforce is, yeah, I mean, sort by opportunity because that's a parent. And we recommend that, I mean, Salesforce recommend that because to prevent any row log errors that you will face or any other user who is working on Salesforce will face at the same time when you're doing the large data volume upload. So object model, as far as I understand, is very, very critical. You need to have your object schema in your fingertips. The next aspect is automation. I mean, once you have object model, then yeah, I mean, you have a lot of functionalities, requirements. You tend to look at automations. It could be trigger, process builder, workflow rule, or flows. And all these automations you will definitely build to meet your business requirement. But the other side is the large data volume, right? So as the large data volume grows in enormous size in your org, then automations can, if not implemented properly, will become a pain point. So you have to take proper decisions like what kind of automation you're going to select and what you can do with automation to improve your processing. So one of the concept, if need be, is skipping your automation, right? There can be situations where you could be data loading large volume of data into Salesforce, and probably you don't need certain object trigger or process builder to run when the data is entering the system. So you kind of tend to look at how you can skip the trigger or skip the process builder or any related automations to facilitate improvement in the large data volume processing. I know there are a lot of solutions of how you can skip. Maybe you can have a custom setting, refer that in the process builder or trigger, just have a flag in the user for whom you want to skip it, mention that in the trigger and facilitate that. So there are a lot of solutions. There are many ways to do it. But the main point is, yeah, I mean, automation and the understanding of automation while handling large data volume is very, very critical. And now the third aspect is what I will touch upon is role hierarchy. Because every org will have a role hierarchy, right? I mean, we will implement our territory management. We could either use the Salesforce territory management feature or we could use a role hierarchy. But in orgs where the role hierarchy is very deep, it keeps on growing and growing, then that will really hamper your org's performance, especially in situations where you're creating data or you're trying to change the ownership of data. The bigger the hierarchy is, that's like increasing headache for you. The main reason is because the Salesforce inbuilt design of implicit sharing, because Salesforce follows that top to bottom kind of an approach, right? So anybody who stays at the top level of the role hierarchy, they will gain access to the data owned by users who report to them from a hierarchy standpoint. So every time you create a data, then Salesforce has to go through this chain of role hierarchy and ensure your data integrity is intact. And data visibility is improper. So if your hierarchy grows, then the time taken by Salesforce Depending on the owner's level in the hierarchy, it will take more time. So that's why role hierarchy maintenance is very key here. And you have to take steps to see how you can optimize your role hierarchy. And if any role in the instance becomes stale, or if any role in the instance becomes inactive, take steps to remove that from the hierarchy so that the number of roles as well as the hierarchy in the instance is within the prescribed limit. So Salesforce normally recommends 10 to 12. I mean, I don't know whether there's a documentation which relates to this, but what I have heard is 10 to 12 is that kind of a magic number. So the moment you go beyond that, you have to watch and maintain your role hierarchy accordingly. So in a just these three, for me, these three are the critical pillars: object model, automation, and role hierarchy. So if you have a proper understanding of that, then that will help you to take appropriate decisions in handling large data volume. So this is what LDB Preps is about. So now let's get into a few of the use cases so that we understand how you can tackle those similar use cases. So to begin with, the number one is 8 million of data creation in instance, right? So 8 million as such is a very big number. So here what we see is you have universal containers. They plan to upload 8 million of customer account data. Now the customer account data is actually maintained in a custom object. The custom object also stores the subscribed product of the customer. So each customer can have a subscribed product, right? So that kind of a data is what this custom object is maintaining. The OWD of the custom object is private, and the custom object has a lookup relationship to opportunity. And there is also a trigger on opportunity, which will run like whenever you associate a line item to an opportunity. And if that line item happens to be the subscribed product, which is mentioned in the table, then the purpose of the trigger is you have to pick the associated customer and populate to a field in opportunity. So overall, I mean, from a volume, you have 8 million of data. There is a custom object that's going to receive this. This custom object is having a lookup to opportunity. The OWD of object is private. And finally, there's a trigger on opportunity, which has to do this data population. So in a way, it looks decent enough. I mean, from a platform and the automation of trigger that is set up is decent enough, but the volume is key now. It's 8 million of data, and the ask is like it has to be uploaded within business hours, maybe within a day. So let's see how universal containers tackle this kind of a use case situation. So one of the solution concept that we will consider to tackle this is bulk API. So as we all know, bulk API is one of the Salesforce features wherein you can bulk upload data into the system. You can also define your batch size while you're uploading the data. And Salesforce, I believe at the back end, it does a multi-threaded kind of a structure based on the batches you're defining. So if you define batches of 2K or 6K, then it splits the data in that many batches based on the batch size defined, and it will process the data in parallel. So it's in a way doing a multi-thread kind of an architecture as far as bulk API is concerned. I have also heard there is a bulk API 2.0, which has a better UI while you're processing the bulk API compared to bulk API. And I think even for bulk API 2.0, Salesforce will automatically determine the batch size while it is processing that multi-threaded way of handling the data. So that's one of the advantages. You don't have to define the batch size while the processing happens. Salesforce will define it automatically. But one catch with bulk API is, as far as I know, it's best recommended like you don't do bulk API in an object which has a lot of automations, because that's going to trigger probably a lot of errors, and your performance will also kind of come down because of the automations in the object. So we just have to be careful, like when you have to use bulk API. Here I'm using because, or here I'm recommending like bulk API because it's only one trigger, right? So it should be okay. Now the next aspect is indexing, right? So indexing, it kind of comes at a place because after we have successfully uploaded the 8 million data, right? Now what happens next? Next, when a new opportunity comes or when an existing opportunity has a change of line item, then you need this trigger to kind of refer against the custom objects data and pick the appropriate customer. And now once the objects data is 8 million, which is very huge for trigger to handle, yeah, we can bulkify the trigger. That's one way to do. But on the other end, one of the Salesforce facility that we can leverage is indexing. So you can index the custom field that you want. especially once you write the trigger, the socket query within the trigger, obviously there will be a where clause. So it's kind of recommended like you look for those columns which are mentioned in the where clause and try to see whether you can index it. And for that, you need to request Salesforce and they will enable the indexing for you. So indexing will help you to improve the query performance, which is very essential because the trigger is something that you need to run very real time, right? So indexing is very key over there. Now, the third part is ownership skew. So here we are in a situation like, okay, you have 8 million of data coming in, but every data has need to have an owner, right? Because it's hitting the custom object. The custom object OW is private. It's having a lookup to opportunity. So every record has to be an owner defined. And 8 million of records, you have to define who is the owner, right? Unless the owner is equally distributed, you are then talking about a situation called ownership skew. And ownership skew is nothing but if a user is owning more than 10K of record, then boom, that's an ownership skew. And the more data a user ends up owning, then that will reduce the platform's performance. It's a very, very bad situation you will be entering into. So we need to find a way to mitigate this ownership skew. So one of the ways is try to find an equal distribution of ownership for the records. That's one way to look at. Or another way will be like if it's essential like the owners will stay like that, then maybe blank the role of the owner. That's one way to do because these kind of steps, right, it will make the owner of the record move out of the actual role hierarchy you have and essentially improving your system performance. So in the worst case, if 8 million happens to be coming under a single owner, then that could be the best step that you can take up. So combining these three solution concepts, let's see how much time Universal Container took to process the 8 million of data. So they took 12 hours only, which was well within the business expectation. And that's how Universal Containers handled it. And it's one of the successful use case that we went through now. Let's go to the next one. Second use case is 8 million of update. So earlier we saw about 8 million of data insert. So now let's look at 8 million of updates. So here we're going to look at contact. The use cases, you have Universal Courier, who is having like 8 million of contact in the org. The OWD of contact is controlled by parent, which is going up to the account. And the requirement is, the ask is to populate the region that the contact belongs to. Now, contact is tied with the account. Account has country data populated in it. And here the ask from business is, okay, you have 8 million contact in the org. I need region populated in every contact record in the system. So obviously we'll tend to go into the bad job kind of solution, right? Any large data volume handling, right? The best recommendation is whatever automation you have and whatever solution you're trying to mitigate it, try that in the sandbox so that you know what are the pitfalls are for it and what all improvements you can do before you can take it up to production. So in this case, Universal Courier tried to do a single batch job and they tried to process 8 million of data. So when they finished processing 1 million, that itself took 15 hours to complete. So by math, 8 million will take 120 hours to complete. And here the business expectation is like within 30 hours, things to be done. So their situation is very tricky now with the 8 million of contact, you have the batch job to process. So let's see how Universal Courier tackle this. So from a concept standpoint, one is batch job and parallelism. So have multiple batch jobs run in parallel. So that's what I'm trying to say here. And parallelism is one of the techniques that you can leverage in Salesforce so that you can divide and conquer the data. So here, since you're populating region on the contact records, you can possibly have one batch job which will just focus on the APAC region. You can have another batch job which will focus on EMEA region, Europe, Middle East, and Africa. And you can have another batch job which will look at US and Latin America. And here the batch job's purpose is like it has to like look up to the object which maintains the country region mapping and then populate the region value into the contact. So having multiple batch jobs running in parallel is a good way to get a better throughput per hour compared to the 15 hours that we got while processing just one batch job. So that was one way to get into this situation solution. The next one is user pin. So user pin is one of the facility that Salesforce kind of extends to its customer on a need basis. So it really depends upon your business use case, what volume you're handling, what expectation business has upon you, the time constraint that you have to finish processing all the data records, right? So in those situations, you can raise a case with Premier Support and request them to pin the user that will be processing this much volume of data. Conceptually, user pin is nothing but Salesforce at the back end is allocating additional resources or additional bandwidth for the user that is processing large data volume. So it's a good thing to have. It also depends on how much improvement this might give, but it will definitely give improvement, be it marginal or huge. That will depend on the situation, but it at least gives you a bit more bandwidth on the user that is used for processing the bench job. So now with these two solution concepts, let's see how much time Universal Courier took to process 8 million. So the sandbox testing revealed 120. The business expectation is 30. But now let's see how much Universal Courier kind of took. They took 16 hours. So with bad job and parallelism as well as user pin on top of that, it was a big time saver for Universal Courier, and they helped finish the 8 million data in 16 hours, which is a big win for business, looking at the requirement and how much they went through. So this is one successful use case for large data volume. So now let's move to the next use case. So the next use case is opportunity data slowness. So this is a situation where we are actually pumping opportunity line item via an integration. So the line item is stored in one system and it's being integrated to Salesforce. So the line item and opportunity data are being transacted across. And Universal Painters, they have an account which has like 50K opportunity record. The OWD of opportunity is private. The org already has 2 million of opportunities in the 15-level deep hierarchy. And to top it, org also has many triggers and automations that they have built, process builders and everything. And the throughput that the ETL tool observed, ETL tool can be data loader or Informatica, MuleSoft, anything. I mean, there are many ETL tools, right? So I'm not naming any, but just as an experience standpoint, ETL tools with just a batch size of 5, they took 750 per hour to process. Which is very, very slow. I mean, if you have like a 30K or something to pump into the system, and with 750 per hour, you're going to like sit through 2 days or plus to finish everything. So that's not ideal, right? And we need to find ways to improve this data volume handling. So let's look at the solution concept. So one of them is data sorting. As I touched upon earlier, data sorting, especially in this opportunity and line item situation, right? It's very, very critical. So one of the things that ETL tool did was sorting the opportunity line item data based on the immediate parent. So in this case, it will be opportunity. In other case, if you have a parent-child relationship, then you can sort your child record based on the parent data. Now, why we do data sorting is to reduce the locking of record. If the data is not sorted, then the lock on the record can be prolonged and you will be hitting long running requests or record lock issues as a result while you're processing the data. And this will end up reprocessing error record back again and again until the lock releases. So that's how, even though data sorting might look simple, but it plays a critical role in situations like this. So that is data sorting. Next is data archival. So here, when you look at the situation, right? So you had account with 50K opportunity record. So earlier we touched upon ownership skew as one of the aspect, right? So in this case, we have led into data skew. So here account is owning more than 10K of records. So data archival is very imminent. We can have our own custom solution to do. Maybe leverage Heroku or run batch job and get that done. And the end result is ETL managed to process like 2K as a throughput compared to 750, which is like 4 times. So this is the successful use case for the third one. Now let's move on to the gotchas. So number one is granular locking. So it's very essential. Granular locking gets enabled in an org, which has a huge role hierarchy. And the purpose of granular locking is it isolates your operation specific to that hierarchy only. So if you're doing any role creation or a user's role update or creating a new user, then granular locking kind of isolates that operation to that portion of the hierarchy where this role is touching, and it will not touch the rest. So which means concurrent processing of users is possible if you enable granular locking. So that's one item. The next item is skipping automation, right? Like I mentioned earlier, skipping automation is one of the things that we might end up doing while you're processing large data volume. So it can be either be a checkbox driven skip solution that we can do, or an alternative will be like you can leverage a custom permission set, assign that to the user for whom you want to skip this automation and process a large data volume. So skip automation is one thing. In the data archival, right? So data archival, the question will be like how you can identify if your data is meeting your archival criteria. So one solution can be like, okay, I'll create a checkbox and determine accordingly. But based on one of the session that I attended, one thing that I came to know is creating a checkbox as a result of a data archival criteria may not be a best practice, because once you request Salesforce to index the checkbox that will identify data for archival, it might end up being a full table scan because of the threshold and indexing calculation that Salesforce has to do. So the recommended is like either you do a pick list field or a text field, because that is more easy to be indexed compared to checkbox. Now let's go to the next one, file space limit, right? So this is in a situation where you have email to case implementation. So every case responses will have a file attachment to it, because your responses to a case will be like email attachments to a case, right? So that is one attachment. And if that email has some logos and all, that's another file which keeps on getting accumulated. So file size limit is one of the key in orgs where you have email to case enabled, because this Salesforce CRM content limit, which is the number of files limit per org, is 30 million. But if you look at an org with large data volume implementation and big case management, then this limit is soon to be hit. So we need to have an eye on that and come up with a strategy to combat archival of files. The next one is your way of processing LDV, right? So you can insert the data, update the data, or upset the data. So what, even as per Salesforce recommendation, it's recommended like you, even if it's an LDV processing, you start with insert first, followed by update, and then maybe to an upset. Ideally, upset is not recommended while you are processing LDV because it's a very costlier operation. And then comes recursive automation. So from a best practice, right, though we have a lot of automations like trigger, flows, process builders and all, it's best recommended that you don't deliver a mixture of that in one object. Don't have 3 automations in one object is one of the biggest takeaway I had in one of the session I attended recently. Either stick with one automation and do with it. You can either have Apex trigger alone, or maybe workflow rule in combination with Apex trigger if need be. But process builders, triggers, and workflow rule, it's a very bad situation you are getting into for that object. One of the key takeaway with process builder is the more process builder, right? The way process builder is designed is it's essential only for a single threaded operation. It can't handle bulk update, or parallelism of updates against a process builder is a big no-no, because process builder execution will consume CPU, DB time, as well as the governor limits, because each process builder update results in a DML update, and that will again loop in the cycle of all the trigger executions, validation rules, and everything will again be restarted again. So you're getting yourself into a loop. So that's one thing. And another aspect of process builder is like the initial load and interview that a process builder is going through. Even if the record matches the criteria or not, the initial interview as such will take at least 20 milliseconds to 80 milliseconds, which is very costly. I mean, because at the end of the day, when you create a record, you need that save operation to happen instantly, right? You can't wait for like 2-3 minutes and ultimately come up with the message like long running request or things like that. So the cost of the query and the cost of process builders execution is very essential here. And also, even if you design the process builder and workflow rule, have the criteria defined properly so that unnecessary process builder or rule execution can be prevented. And like I said, do not mix all the automations in the same object. It's in a way an overkill. So the last one, soft delete and hard delete, right? So we all know, I mean, whenever you delete a record, it goes to recycle bin, it stays for 15 days, and then after that, it goes to the hard delete. But there is another process which is beyond that, which is a physical delete operation. So what happens to the data after the 15 days is it goes into Salesforce internal physical delete process, and that is a job which picks up the data and keeps on permanently deleting the data. Now, in situations where you have ended up deleting a lot of data, right, then it's better you inform Salesforce like you have probably deleted maybe millions of data based on your situation, and request them to prioritize your physical delete operation. Otherwise, if large volume of data stays in recycle bin, that will surely impact your query operation because the data is still not yet fully deleted from the DB. So the DB performance will be impacted. And another thing which I came to know is truncate custom objects. So that's one of the facility where that clearly bypasses the recycle bin's 15 days data storage. I mean, it bypasses the recycle bin, and any object, custom object that you truncate, it's direct physical delete that's invoked. And you can also initiate hard deletion via bulk API. So that's another thing. And then yeah, like I mentioned, you have to interact with Salesforce support while you are doing soft delete. And if your recycle bin size is growing, then you have to maintain it properly. And then compared to process builder, you have lightning flows, which has been recently introduced. That is much more bulkified and much better tool compared to process builder. So a few of the documentation in Salesforce kind of indicates it's better to transition from maybe workflow rule and process builder onto the flows because that's better designed. And the backend infrastructure is much better compared to the process builder and workflow rules. So it's a good alternative that we can look at. And one advantage is the cost of execution. And last item is skinny table. So skinny table, it's what I understood is like it's a shadow table at the back end. And whenever you have a bad job or any common query, right, which keeps on hitting the system time and again, then it's better you reach out to Salesforce and request for a skinny table. Because ideally for any query, if it has a combination of standard and custom fields, Salesforce is kind of pushed into doing a join between the tables and then proceed with processing of data. But the advantage with single skinny table is like a single table which will have all the fields in it. It will map that to the data, and your query performance will improve a lot. And to my understanding, bad job is best served if you have skinny tables enabled at the backend. So that's all the guidelines from me. And next is all the references I took. There are a few blogs which are very well written, and it's good content, and you can learn more on large data volume. And finally, I would recommend this Salesforce certification if you want to know more about large data volume. Get into yourself, go through this journey of getting this certificate because it will help you to learn more on large data volume handling and equip yourself for your own situations at the org respectively. So that's all I had, and thank you so much.
Thanks, Mahesh. There was one question, thanks, Manoj. There was one question, common question that if, where can we find any documentation related to the user pin? Because if we Google, we don't have it.
Yeah, it's not documented. It's something that we learned using on few of the use cases that we went through. So we had situations like millions of data to be processed, and it has to be done in a short interval of time. So when we spoke to the Salesforce senior technical architects and all, then they helped us in giving us this facility. So it's nowhere documented. And when I explained also, it kind of goes through their own internal approval process. So it's not like for every kind of a load, user pin is a solution. Then they won't entertain. It actually depends on the use case, the org situation, and the business readiness. I think that's what matters. So it needs some convincing, but it's a conversation you will have with Salesforce support. And once they understand your criticality, then for sure they will enable it.
Great. Okay, there's one more question which we can take at the end of the session. So just for your preparation, there's a question from Sammy asking any ideas for automated data archival to an on-premise database. But we can take it at the end of the
sure.
session. So let's hand it over to Kid.
Okay, thank you.
Okay, let's see. Let me share my screen. This one. I hope you can all see my screen. So yeah, let's talk some more about LDV. Come on, yep. So there we go. Rule number 1, this ain't Jurassic Park. Why I put in the slides is because the first question you should ask yourself before you handle LDV is whether you should handle LDV. I've been in quite a few LDV implementations, and to be honest, I think none of them should have been LDV, because it's very important to only have the data in Salesforce that you actually need in Salesforce and not just put anything in there. So really you should ask yourself, should an LDV reside in Salesforce? If you can prevent an LDV in Salesforce, you should definitely do so. And a few common things to consider here is the data relevant and active? Only relevant and active data should be in Salesforce. If it's not relevant to a process that is run on Salesforce, and I don't mean a process in automation, but a process concerning users doing a task on the platform. If it doesn't support that, then it shouldn't really be on Salesforce. Also make sure you archive and clean your data. So if a record is no longer relevant to a process in Salesforce, make sure it's archived to maybe an offsite backup system or an archival system, but at least don't longer have it in Salesforce, because it will affect your indexing performance, which means that every time you write to a record, it will have impact on the performance there, because the index might have to be updated, and at the same time all your queries will run slower as well, because, well, you have more records in your object, so there's more data to search through. So if a record is no longer active, make sure you archive it, and also keep your database clean. Another aspect to consider here is that the master record doesn't necessarily have to be constant throughout the record's lifecycle. So Sales is a CRM system, of course. So you might start out with a lead and go through the opportunity stages. But once you go to order and then start the order fulfillment, it might make more sense that Sales is no longer the master of that record, but that ERP becomes the master. And maybe from that point on, you don't even want your records in Sales anymore. You might just keep them in just your ERP and only get them back into Salesforce when they become relevant again, for instance, during a service process. The next thing to look at is how's the data used. Salesforce itself is quite strongly read optimized, and you see that's very much so in the data model, which is very denormalized. But you have to consider, how is my record used by the system and by the users? Do I, for instance, view a record over 1,000 times more than I write to a record? Then it makes very much sense to optimize for read performance. And that means a denormalized data model, for instance, and also static data. So that means that you don't want formulas on your record to determine the data on read, on access, but instead you might want automation to update the data statically, and that's then just there, accessible, readily accessible, when you run a report or query, or just open a record and view it on a detail page, or you open a list view. So the data is already there and it doesn't have to be calculated at access. Make sure you first try to determine, how is your data used? Do you know the ratio between read and write, and can then determine for which one you should prioritize and optimize? Then there's passively active data. So there's data, for instance, in a service process, you have a customer and he's bought a product from you and he has warranty on that product. So he can request service on that product. But maybe the ratio of people that have a product versus people that request service is only 100 to 1, or maybe 100 to 5. So that means that you have 20 times or 100 times more data in your Salesforce org than you might need for that object. So in that case, it might also make sense to have the data in your ERP, because it's about fulfillment, about providing a service or providing a product, and then maybe get it back into Salesforce through automation, for instance, integration, for instance, when you actually need it. So when a customer requests service, there will be a channel connected to Salesforce, for instance, web to case form, and when that case is logged, you trigger some automation that will trigger an integration and retrieve the relevant records from your ERP so that it becomes available again in your Salesforce. That's also something you can use to make sure that your Salesforce org only contains the active data. Then some data model considerations. I already mentioned before, normalized versus denormalized. Below you see an example in the images. The left one is from Sage CRM. I did a migration once from Sage CRM to Salesforce. And on the left, you can see all these objects that basically just become these three objects in Salesforce. And why is because email, phone, and address are all separate tables in Sage CRM and have link tables to link them to multiple other objects. So for instance, email can be linked to company, which is accounts. It can be linked to person, which is contact. And the link tables decide how it's linked. And in such data model is very strongly write performance optimized because you have a very selective functionality on an object on a table. You only use it for one purpose, which means that all the automation and the functionality on that table will also be very limited. If you put all this information on accounts, then it means you have more processes running on accounts, you have more data running on accounts, you have more automation running on accounts, so you will access all that data more often, and you will also trigger that automation more often. And most automation, whenever you update an account or insert an account, might not actually run, because you'll, of course, do old map, new map comparisons, or similar in point-and-click automation like Process Builder. But still, it has to evaluate whether something should happen or not. And all that evaluation takes time, even if nothing is happening. So again, make sure you determine whether an object is mostly used for writing data or mostly for reading data, and optimize accordingly. And another thing to consider is something I mentioned before about the passively active data. So if you want to retrieve data on use, on requirements, so for instance, when someone requests service, then it will require more performance at that first attempt because it's not in the Salesforce yet, so you have to retrieve it. But the benefit is that the rest of the time, when you don't actually have that, the performance will actually be better because the object is smaller. And also it requires lower storage usage because, well, again, the object is smaller, so you don't have as many records in Salesforce as you would if you always have them available. But another thing to consider is regarding the normalized and denormalized. If you want to optimize for write performance, so account and contact, of course, are standard objects, but with custom objects, you can decide for yourself how you want to design your data model, and you might want to go for a more normalized approach, like on the left side. Then you have to consider that, well, you have many more objects, and all objects with 3 exceptions in Salesforce are 2 KB per record. So you have all of these objects instead of just 3. You will require, well, let's see, 3, 6, 10. You require 3.3 times more storage than you would if you only had these 3. So also make sure that if you want to optimize for write performance, that you do need more storage. When you have decided that you definitely want that LDV in Salesforce, probably comes out of an external system the first time you want to move it into Salesforce. So you have to do a migration from that other system into Salesforce. First step there is to actually identify the LDV tables. While considering the first step, the other steps I already mentioned, you've probably already done that by now. Then you decide what data should move to Salesforce. You calculate the required data storage. And one of the biggest pitfalls is that quite often you see they already have Salesforce. It's not that they do a greenfield implementation. They already are using Salesforce, maybe for a couple of years already. So it's a live org. You can just shut it down for a while or just not start using it yet. It has to keep running, and there's already data in there. So you cannot just simply insert all the data from the other system into Salesforce either. You have to merge it. And for that merging process, you really cannot use the simple ETL tools that aren't really ETL, to be honest, like data loader, or for instance the Jitterbit data loader, that are basically just extract and load and have little to no transformation options. You really need a real ETL tool here to leverage that. Another thing that's very important in the pre-migration phase is that you, especially if you're a consulting partner and SI, that you talk with your customer and determine the metrics for success. Because if you're migrating millions of records, it's near impossible to have 100% success rate. And even if you come very close, I've had migrations with millions of records in a single object that's had a success rate of over 99%. But as it turned out, among the 0.2% of records that failed were pretty much all the key accounts. So you have to identify the metric for success, what is the customer expecting, and also discuss the diminishing returns. It might actually take more time to finish the last 2% as it took to do the first 98%. But also make sure that you know what definitely has to be in there, what cannot fail under any circumstance. Next step, have a migration plan. So identify the team and stakeholders on both sides. Agree on responsibilities per party and role. Very important. This also has to do with tooling and with hardware, which I'll get into later. Again, as well, determine metrics for success. Denormalization plan. As I mentioned, Salesforce is already by itself, the native data model, the out-of-the-box data model, is strongly denormalized. Most older systems, especially non-cloud systems that run on-premise, have very normalized databases. So you need a denormalization plan to, when I go back to the previous example, to go from something like this to something like this. And that might not always be very obvious how you should denormalize that. Once you've done those steps, you can determine the migration order. So in what order should I import the tables from the other system into Salesforce? Because you have dependencies, of course. You cannot, at least in most cases, you cannot or don't want to import child records before you have the parents. So you have to make sure that you import them in the right order. And very important, you want it repeatable. So you have to make sure that you write down every step exactly the way you do it, and that you test your whole plan at least once end to end before the final migration. Because you're going to turn automation off, you are going to request higher limits with Salesforce. You're going to request features like defer sharing recalculation, and all those things you have to know so that you can do it the exact same time, exact same way when you do the final migration. Then the migration approach, as I mentioned, you pretty much build a sort of integration between the two systems. So you don't just extract the tables from the old system and import them in Salesforce right away, because quite often you cannot do that because of the normalized versus denormalized. But you also have different ways the data is stored. You might not always have a one-on-one match between certain tables even after you denormalize the data. Another thing is that the functionality might be different, the validations might be different, field values, for instance, with pick lists might be different. So you have to handle all of that, which requires transformation, and that's best done in ETL tool where you can build a whole sort of flow to leverage the functionality to do that. Tooling is not just the ETL tool itself, it's also the hardware it runs on in the case you are not using a cloud ETL tool. I very much recommend running ETL tools if they are not cloud-based on a dedicated integration or migration server. And you want to make sure that you have all the proper access, like VPN, RDP access to the server, which makes sense, of course, otherwise you can't access it. But other than that, you also want to know the maintenance windows, when will be rebooted, when will they have updates, stuff like that, to make sure that you don't run into the issue that the admin of the server didn't know you were running migration on it, and you start a migration somewhere late in the afternoon, and you get back the next morning hoping it will be finished, and you find out that it's actually crashed after 2 hours because the server automatically started updating and rebooting. So make sure you don't have stuff like that happening. And also make sure that when you work with LDV, you need quite a bit of bandwidth, both on the hard drives as well as on the network, and also require quite a bit of memory. So make sure that all those resources on the server and on the network are allocated to you. And another thing already mentioned by Manoj is that you want to look into parallel runs. In some cases, it can be very worthwhile to run multiple parts of your migration, so multiple flows in your ETL tool simultaneously when the objects you are importing or updating have no relationship whatsoever. If they cannot affect each other's automation, if they cannot affect each other's sharing, then it's absolutely fine to process them at the same time, because you win a lot in the total run-through time. So make sure you investigate what objects impact other objects and which can be run simultaneously. Next step is determine the best place for data prep and validation. Sometimes this can be done at the source. This is especially the case if it's a system that will be deprecated straight away after the import. If there's a lot of tooling there, and for instance, they have a Microsoft SQL, so a Transact SQL database with a few very skilled SQL admins, database admins, then it might make sense to already prep the data directly in the SQL database, maybe create additional tables in which you already performed the denormalization, data cleansing, maybe data enriching, the merging of live data already in the Salesforce org right now, merged with the data in the old system. You might already want to do that in the old source then. In most cases, that's not possible or not desired because they might want to keep the old system for a while as a backup, still be able to access it, and also that the system still works. So you might not want to alter the database. And in those cases, it can make sense to also connect the ETL to a staging database. So basically you set up an additional database. So you have the source database on one end, the Salesforce database on the other end, which is the endpoint, of course. But in between there, the ETL also leverages a separate staging database in which it can do all the prep and basically come up with a version that can be imported directly into Salesforce. And the primary reason for that is performance. Because if you already have the data ready, then the in-flight calculations will drop to pretty much zero because it can readily be imported into Salesforce without any additional transformations or changes to the data, which is also what you want. If possible, always make sure the data is readily available to write to Salesforce, and you don't have to perform all kinds of automation and calculations in Salesforce. An important thing to consider here is that you also want to prep for the automation that would run on it in Salesforce itself. So if you have process builders in Salesforce, which are the enemy of LDV, don't use them with LDV, but also triggers, maybe in old org workflow rules, in newer orgs maybe the new flow triggers. If possible, disable all of them and do what they would do in your staging database. So let the ETL tool handle it off platform. And again, have the data readily available, and make sure you can disable it for all that automation, so that the in-flight time and processing time will be much shorter, because the data doesn't have to have any processing done on it. Another option, other than source-based prepping or staging database, is intermediate files. This is mostly interesting if you don't really have ETL tools and don't have the budget for it either. Then you might be able to do the prepping in a staging database not connected to an ETL tool, and export those as, for instance, CSV files, and then use data loader or other very simple import-export tooling to write the data to Salesforce. But if you have the other options available, I wouldn't go for that one. And as last point to mention here, data aggregation. This comes back to the point of, should you want the data in Salesforce? And this is especially the case with reporting, and more so even if the customer doesn't have a separate BI system. They might just want insight in their data, but they might not need the full data set. So if, for instance, they only want to see the revenue and profit numbers and the cost in a certain period, what you basically need is something similar to a reporting snapshot. You need the aggregate result of that data, but not the full data set. So in those cases, if the only requirement for having that data in Salesforce is reporting on aggregates, then it makes much more sense to already do those aggregates where possible outside of Salesforce and just import the aggregate data. And this can also be an archival strategy where you archive the full records off platform, but then you keep an aggregate version of the records in Salesforce, so that you can still see in Salesforce how many payments a customer has made, what the total amount of those payments sums up to, stuff like that. So you can keep the full history in terms of numbers in Salesforce, but you don't keep the full history in terms of actual records in Salesforce, which can save tremendous amounts of data. I have seen ratios where the data drops 1,000 to 1 factor just because we were able to aggregate and keep the full records off platform. Oh, I think I skipped one there. No. Next step, testing and reruns and error processing of your migration. Always make sure you incrementally test your migration. You don't want to start off with a full batch right away, especially if you have an LDV, of course, because it might be millions or tens of millions of records, or even hundreds of millions in some very rare cases. And you only want to start out with just a few, maybe just 10 records. And then you build up 1,000, 50K, 1 million. And after that, I'd say take 1 million as the second largest. And finally, you want to test your full migration at least once on a full copy sandbox, also for benchmarking, because you want to know how long will that batch actually run, how long will it take, and take a safety factor in there, because the performance from day to day can strongly differ. I've seen benchmark differences between full copy sandboxes and production of a factor of 5. And while it's rare, it can definitely happen. So make sure you take a safety factor there. Fortunately, though, in most cases, production will be faster than full copy sandboxes, but it's not always the case. Another important thing for the testing phase of migrations is you don't just want to verify results by random sampling. Just, especially if you have an LDV with millions of records or tens of millions, it doesn't work clicking through a few records and saying, well, these all look fine to me, looks okay. Because you only tested not even 1 per 1,000, now you tested a few per millions. So it's not very representative of the full data set. So also here, aggregate results can be very useful to test your data. If you already know from the old system, you had 1,000 records in Q3 last year for a certain customer with, let's say, a revenue number of X and a profit number of Y and a cost number of Z. then you can run the same aggregate queries on Salesforce, maybe off platform, because it might be too heavy to run directly on Salesforce, but maybe create the data that you import from Salesforce into a staging database again and perform aggregates to check if all the data is actually there in the proper format. And with aggregate queries, you cannot pinpoint the error very exactly, because you know, well, there's an error in my aggregate result maybe, but I know it's one of the records targeted by that aggregate query. So then you have to do a further investigation, of course, but still it's a much more reliable method to make sure the entire data set imported, updated, changed is processed properly, instead of that you only do random sampling. As mentioned before, test your full migration at least once. So you don't want to do parts and then later on chain it together when you go to production. Also test the full migration at least once end to end in exactly the same time frame as you would on production. So that you have the full plan, you know exactly how each step will take place, you will know how long it will take, who can do it, who will do it, all those things you need to know. And in some cases it makes sense to do a pilot period or a shadow run, so that you maybe before you go live, people are still working on the old system and maybe shadow on the new system, so on Salesforce for a while. You might want to do a pilot with a few super users, but maybe not go straight from the old system to Salesforce. Then optimizing the migration, because you do it incrementally and because you benchmark and do all of steps on sandboxes before, you already know how long everything will take, you know what actions have to be taken, and you might be able to automate some of those manual steps, because really you want to let the system do the work for you. You don't want to wake up in the middle of the night because one batch finished and another batch is about to start and you have to do some manual steps in between. No, you want everything automated and minimize the manual steps and make sure that all the manual steps that you still have to do are either completely at the start or completely at the end, but not in between, because, well, you, like I said, the performance can differ. So if suddenly a batch is done in the middle of the night, you don't want to be the one having to wake up then and do something manually. Make sure you keep track of your API call limit per 24-hour running window. And also make sure that you keep track of the total number of batch jobs allowed per 24 hours, which is 15K for the V1 of the bulk API. Another thing to consider is staged imports. This is especially the case when you have an object that has many parent records. So if it's not just one parent record, but many, you can easily run into locking errors when you import with the bulk API, because multiple chunks will be processed simultaneously, and not all the parents might be the same for those records in the various chunks, but some might have at least one parent that is similar, and then you can run into locking errors. So it can be an effective way to remedy that is to first import pretty much all of the data of the record, but only with the primary parent. So for instance, for a contact, you want to have the account in there, and then order the data by account ID to prevent locking errors there. But then later on, with updates, expand the data on that record by adding the other secondary parents. The insert plus update versus upsert already been covered, so I'm going to skip that one. If possible, use parent mapping on sales ID, because it performs much better than using the external ID from the old system. So while you have the option with upsert to use the external ID from the old system as the parent reference, if possible, always go for the sales ID, because it will perform much better. And then there's block changes. Block changes are things like audit fields, closed cases, activated contracts. So stage imports won't work for those. For instance, with the audit fields, you can only set the created by, last modified by, create date and last modified date on insert with the old system values. But as soon as you update, the created by and created date, of course, will stay the same, but the last modified by and last modified date will change into your user or the one you use for your integration and migration. So make sure that if you want to have the old audit fields, that you cannot do stage imports then, which might mean that you cannot run parallel processing on your batch jobs, which will of course affect the performance of the jobs. So that's something you definitely have to consider, because yeah, if you want that data in there and you run into locking errors, if you don't do a stage import, you might want to disable parallelism and maybe also lower your chunk size, which of course heavily affects performance. Another important one that you definitely don't want to miss is outbound email. There's tons of functionality in Salesforce and automation that you can build yourself that will send out outbound emails, and you don't want those enabled when you do a LDV migration. For one, because of the emails itself, but also because of performance. So make sure all of those are disabled. And just for safety, make sure your email deliverability is also disabled. Another big issue performance-wise can be non-native rollups. So of course we have the rollup summary fields, but there's also ways to roll up differently, like the decorative lookup rollup summary tool from Andrew Fawcett. And of course you can also build your own versions of rollups. You definitely want to disable those during an LDV migration, because they will very strongly affect the performance of the migration. Then for the automation itself, like I mentioned, Process Builder really is the enemy of LDV. It performs very poorly against large volumes. So whenever possible, don't use it at all on an LDV object. Not just for migration, so you definitely want to disable it there, but as the best practice, I would say never use Process Builder on an LDV object, because it just performs too badly. Flows are fine, Apex also fine, but make sure that whatever you build, it's always bulkified. Of course, the maximum chunk size for automation is 200 in Salesforce, but just to make sure everything works also against all the other limits, just throw 1 million records at once to see how it performs. If it can handle 1 million, it will also handle 100 million or even more than that. So make sure that all your automation is bulkified. You never want anything, even if you think, well, this will only trigger if a user does an action on a record, click a button, for instance. Doesn't matter. Whatever you build as underlying automation, everything is always bulkified. So don't just assume only one record will enter the context. Always assume it will be 200, and even then make sure that it's not just can handle one chunk of 200, but also thousands of chunks. If for any reason you do want to use Process Builder, make sure you avoid these kinds of situations. If, for instance, you have a filter on a record you want to update, this will not run bulkified. So if 200 records enter the context, you get the SOCL 101 limits error, because you will go over the 100 SOCLs per context limit. And this is one example of what you want to try to avoid. But in any case, you want to avoid accessing the database multiple times in one context. So you have before save automation, then the save and after save automation. Process Builder, of course, is an automation type that only runs after save. So never use it for same record updates. So if you, for instance, this is a Process Builder on account. If you have a Process Builder on account, you never want to update fields on account. If you do that, you always have multiple invocations of the database. So you have the save context, then the Process Builder starts, and it will again save to the database. And especially if you do this, it will not just do one save. No, you have the save already at the start before you even go in the Process Builder, and then a subsequent one, and another, and another, and another. And that way it becomes much, much slower, because the automation layer in which all the calculations are done, all the processing is done is hundreds of times faster than the database layer. So whenever you go from the automation layer through the intermediate layer, leveraging all the transactions between the two, to the database layer, it can easily take hundreds or a few hundred times more time to process that context than it would if you would process all the data in the before context and only have one save. And if for any reason you need an after save, do it async. So in a synchronous after save context, you trigger your async automation, but you don't actually do anything. You just queue it up basically, and then in the async context, then it doesn't affect any user performance anymore directly. Then you can do same record updates in after context. Then we get to reporting and query optimization. A few things are already mentioned before. One of the most important ones to start with is deterministic versus non-deterministic circle, which I'll get to more in the next slide. Circle selectivity, which means how many records you target as a fraction of the total sum of records in an object. Using semi and anti joins. Semi and anti joins can be very effective because pretty much all the SQL languages have semi and anti joins. Also Oracle SQL, which is the underlying database of Salesforce. But what they do not have is dot notation and parent-to-child queries that you have in SQL. So you have to keep in mind that anytime you use queries like those, they will perform much worse when they have to be translated by the query optimizer to an Oracle SQL query than when you can use it with only semi and anti joins. So for instance, if you want accounts with context underneath with certain specifications, don't just query context with those specifications and put the account ID in the select statement, but instead do select the fields you want from account, where ID in select account ID from contact, with then the field you want on contact, because that's a semi-join. Not in would be an anti-join, and that way you can get much better performance out of your queries than when you use dot notation to access parent fields, or when you do parent-to-child queries, where you have an inner query in your SQL query to retrieve the child records. Once all your queries are deterministic and you respect the so-called selectivity threshold and make your queries as selective as possible, that goes both dimensions, by the way. So SQL selectivity is vertically, so it's about the number of records you retrieve, but it also goes horizontally, so the number of columns you want. There's no limit on that except for the total runtime of a SQL query and total number of characters in your SQL query statement. But still, it performs much better, of course, if you only retrieve the columns that you actually want, the fields you actually want, and not just get all the fields. This is especially applicable with the new functionality in SQL to select all the standard fields or all the custom fields or all fields. Only use that if you absolutely need it. And if, let's say, there are 30 standard fields and you need 29, yeah, then sure, you can use it. But if there are 30 standard fields and you're only going to use 2 of them, don't use the select all standard fields, but only select the fields you actually want. This always applies, but especially for LDV. If your queries still perform poorly after you've used all these measures to mitigate the LDV and optimize query performance, then you can look into custom indices. So any field used in the where clause that doesn't have a standard index, you can log a case with Salesforce to request a custom index. You have to provide some justification, but usually that's fine, and they will enable a custom index on that field for you. And that will prevent Salesforce Query Optimizer from doing a full table scan when querying those indexes. But keep in mind that you then also, yeah?
Sorry to interrupt, but we are overrunning for the time, so probably.
Okay, well, this is my second to last slide, I think, so I think we should be fine. Okay, I'll speed up a little. Yeah, so make sure that if you have a custom index, that you still respect the circle selectivity for that index. If you still run into trouble, you can look into skinny tables, again a feature that Salesforce has to enable for you, and you have to provide the columns that you want, and then a table that's automatically updated vertically, so the records will be updated, but static horizontally. So it will only have a few fixed columns, and any reports or queries running on those fields on an object will automatically use a skinny table and also perform much better than when it would do a table scan on the object itself. Yes, this is already mentioned. These are just some numbers around the actual limits. And the non-deterministic circle is basically circle that wouldn't always get the same result, even if the records have not changed. So for instance, not equal to null, equal to empty string, leading wildcards, not in, any of those are not deterministic. So we want to do the opposite. If you have 10 picklist values in the picklist field and you only want 8 of them, don't select not in and the 2 you don't want, but instead do in and the 8 you do want. And whenever possible, don't use filters and formula fields that either use cross object or relative date values like now or today, because all those will not be deterministic as well. And we'll always do a full table scan, which can perform 100 times slower than an indexed query. And I think that's it. Yeah. So yeah, thank you for for having me present to this SAIMA group. And yeah, that was it.
Great. So there was one last question, and I didn't find any other questions, but the one which we had put on hold, if you would like to answer that, Manoj.
Is that regarding the data archival one?
Yes. So any ideas for automated data archival to an on-premise database?
Yeah, so there are few ways. One that comes on top of my head, just as a safe approach, right? So to begin with, because we need to archive the data from Salesforce actual objects, be it opportunity or any objects in the system, we need to give business a way to access the data. If at all we have archived, you might face a request like they need to access the data even within the Salesforce platform. So probably you can start with a bad job, which can delete the actual data but store in a staging table, maybe in Salesforce. But from there, then you can then store that in on-premise. Either we are putting that table data into Heroku and Heroku talking to that on-premise database, or via an ETL tool, which will then communicate to the on-premise database. So those kind of things we can work it out. So there are ways to do. I mean, you just need a middleware or an ETL in between that can communicate between Salesforce to the on-premise application. Because the volume of data that you might end up archiving is a huge volume. That could be a way to go.
Great.
I hope that helps.
Yeah. I think, did that help your question, Sammy? I don't know if Sammy is still in call.
Seems so. I think we got one in the chat saying great, thank you. So
yeah, okay. Great. Well, that was really nice. Thanks, everyone. Oh, I think there's one more question. What about divisions? Will that not help the performance of queries?
It is, I think, as per the documentation of Salesforce, it's also one piece that will help you improve the query. Yeah, that's a good comment.
Okay. Thank you. Well, there's a common question from everyone. Will the slides be shared? Yes, of course, we will try to present the slide, share the slides with the recording as well. So Great. Well, I wish everyone good luck and thanks for joining the session. Stay safe, take care, stay healthy. Bye-bye.
Take care. Happy
Thank you all.
recording.
Thank you.
Bye.
Thanks.
Thank you.